Hi there, and welcome to this introductory video on data flow diagrams, also known as DFDs. I hope this video can get you started on diagramming a system you're working on and lay the groundwork for creating a threat model of that system. I've gone ahead and made a free Miro board for you to start from, so you can hit the ground running. A link to this board is in the description, but for now you can just follow along with the video. If you already know exactly what a DFD is, feel free to go to this video where we'll be using this Miro board as a template. So let's explore what a data flow diagram actually is. Here we see all of the elements that are typically used in a data flow diagram, and as you can see, there's not really that many symbols to consider. There's a rectangle, a circle, and a cylinder, and that's basically it. You might be wondering when to use which one and how to connect them and why those red dotted lines are there, and we'll get into that soon, I promise. But first, it's important to understand what a data flow diagram is actually meant to accomplish. As the name already suggests, a data flow diagram is a diagram that helps us explain how data flows through our system. Let's start on the left where we see an external entity which we depict with a rectangle. Now, an external entity can represent two things. Either it's a human user of our system, or it's an IT system which is outside the scope of what we're modeling. In any case, this rectangle represents something over which we have no real influence. In other words, we do not manage what happens there. At the same time, it's usually either a source or a destination of data. For example, an external entity could represent a patient using a medical mobile app on their phone. It could also be an external IT system like an identity provider, an FTP server where we fetch files, or a mail server that we use to outsource the sending of emails. Best case scenario, it's a system created by colleagues within our company, but it's not a system we include within the scope of our design. The element in the middle, represented by a circle, is a process. This is an IT system that's under our control, so we have a say in how it works, and hence we have control over how it can be made more secure. A process typically receives data and makes decisions based on that data. These decisions are made by the rules that were programmed into it, so for example, the process could decide whether or not the received data should be stored in a database. Maybe the data looks suspicious and the process blocks the sender from even connecting again in the next hour. Whatever the case may be, we as the designers and developers of the system have full control over which decisions are made and what their consequences are. This is also what makes it different from an IT system that's an external entity, where this behavior is decided by someone else. Moving to the right side of the diagram, we see a data store, represented by a cylinder icon. In some data flow diagrams, you'll see this element drawn as two horizontal lines. That's also fine, but the free edition of Miro only has a limited set of icons available, so we picked this one. A data store is a location where data is persisted. Important to note is that the data store does not make any decisions on the data that it stores. By itself, it can be the cookie store of a browser, a file on disk, or a removable storage medium like a USB stick. There's almost always a process in front of it that handles, for example, the authentication of the entity that's asking to store data there. Take the example of a file on disk where the operating system decides who can access its contents. This decision isn't made by the file or the disk, it's made by the file system, which we would then draw as a process. The same goes for a database where there's a database engine deciding if a specific query is allowed. Data flows are represented by arrows that indicate the flow of data in our system. We typically use a single-headed arrow to represent a data flow because it usually moves in one direction at one given time. There can be bidirectional data flow, as seen in a TCP handshake or the request and response model in HTTP, but these are not happening all at once. Also, the type and sensitivity of data that is sent is usually not the same as the data that's being received. To distinguish this, we use two separate single-headed arrows. The direction of the arrow doesn't tell us anything about whether it's a push or a pull. It only shows us in which direction the data is flowing, not who initiated it. What's also important when drawing data flows is to label them to clarify what data points are being transported, or at the very least what kind of operation the data flow supports. In the next video, we'll get into an example of a mobile medical app where we'll see labels like username and password, but instead you could also label the data flow with the verb authenticate, which implies that a username and password are being sent. For now, it's enough that you know that data flows should be clearly labeled. If you are drawing data flow diagrams simply to describe a system, then that's it. You don't need anything extra. However, the use of DFDs in threat modeling requires one more thing, the trust boundary. Trust boundaries are represented by red dotted lines intersecting the data flows between elements. Trust boundaries represent points in our system where we think an attacker could execute an attack because they're interested in accessing the data or the element where the data is going. The collection of all trust boundaries in a system is often referred to as the attack surface. That's it for this video on data flow diagrams, but the template has a lot more that I didn't want to cram into one video. You can check it out with the link in the description. It also has a tips and tricks list where I've compiled some common pitfalls when drawing data flow diagrams. There's also a ready-to-go library to copy from, and in the next few videos we'll be drawing a DFD diagram for a medical mobile app with a cloud API and an identity provider. If you're interested in seeing more threat modeling related content, let the YouTube algorithm know by liking this video and subscribing to our channel.